Alright, Algebra 2 Trig Honor students. So here's the continuation of Chapter 1 to Chapter 3 lecture. It's a part 2. Okay, so take a look at that, number 22. So for imaginary number, so I, we do know that it's always considered square root of -1. If we do see that I square, so I squared, then that would be square root of -1 times square root of -1. Then that would be considered, this one would be considered -1. Because that, it's just like a square root of -1 quantity square. Okay? And then I to the power of 3, then that would be considered I squared times I using the properties of exponent. So I squared is -1, so -1 times I, then that would be considered -I. And then I to the power of 4, so we do have I squared times I squared. So -1 times -1, then that would be 1. And then I to the power of 5, so which consists with I to the power of 4 times I. So then that would be considered 1 times I, which is I. So for those you might be wondering, what about the absolute value of a complex number? So try to sketch the graph of -3 plus 4i on the imaginary plane. So for the x-axis, it's still considered a real axis. But for the y-axis, this one is considered the imaginary axis. As you can see that I put in y sub I, so that means it's the imaginary axis. So once you put in this, the point here, so it's not just the point. Well, you'll see that in a minute. So it's -3 to the left, 3 units to the left. And then it's 4 units up. 1, 2, 3, 4. So you see that the point here, this one is called the point, the end point. And then this one's supposed to be pointing with the arrow, or like a ray in geometry. So as you can see that this one, it put in like a dotted line here. It's a right triangle. So the x-axis, so this one, it shows the unit on the x-axis. So for the real axis, it's 3 unit to the left. So that's why it's -3. And then for the y component, so this one's 4 units, or 4i unit. Okay, so that would be the graph for the imaginary and the real number, the complex number. Now, but the thing is that, what about the absolute value? What does that mean? So absolute value, that means you want to find the distance, you want to find the length of the ray. Again, this one shows the end point. You might be wondering, the ray doesn't, it has just one end point, but somehow this one, it shows that it's not just the direction, but also it stops right here. So what we need to do, we need to find the magnitude. Magnitude, that means the distance of the complex number. So the way to find out is by using the Pythagorean theorem. Again, it's a right triangle. In order to find out the hypotenuse, the distance of the hypotenuse, we need to use the Pythagorean theorem. So this one would be considered -3 quantity square, and then plus 4i quantity square. The I, we don't need to use that, because that just, we just want to take out the number. So I, there's no need to put it in, because that's just the indicator of the imaginary number. Okay, so basically just -3 squared plus 4 squared. So 9 plus 16. So we do have 25. And then square root of 25. So then that'd be 5. Again, anytime that you want to find the absolute value of the complex number, that means you want to find the magnitude or the distance of the ray. Okay? So now, what about simplifying rational, not rational, imaginary expression? So the way to do it, if that's a monomial, so you want to multiply that, the same denominator, top and the bottom, -7i, or basically this one you can just multiply by I, top and the bottom. You can do it either way. So -28i over the denominator, then that'll be considered 49i squared. Okay, so one thing that we notice, I squared is -1 according to the I to the first power, I to the second. So this one is actually called the I cycle. So -28i over negative 49. And then top and the bottom number we can reduce by negative 7. So that turns out to be 4i over 7. Or 4 over 7i. Okay? And now 26. So what happens if the denominator is just considered a whole complex number? It's a binomial. So what we need to do, we need to multiply by the conjugate. So the conjugate, if you guys do remember that the difference of 2 squared. So let's say a plus b, that's the original form. So the conjugate, it's always considered a minus b. It's almost the opposite. So the denominator here, we multiply by the conjugate. So we multiply by 3 plus 3i, top and the bottom. And then for the denominator, so that just considered the difference of 2 squared. If you do notice that a plus b times a minus b, it's always considered a squared minus b squared. Difference of 2 squared pattern. So 3 times 3, that's 9. Negative 3i times 3i, negative 9i squared. Again, we're going to deal with the I squared later. But now, what about the numerator? So for the numerator, guess what we have to do? We need to FOIL. First, outside, inside, and last. So negative 10 times 3, negative 30. Negative 10 times 3i, negative 30i. And then 3i times 3, so plus 9i. And then 3i times 3i, then that'll be 9i squared. Okay, so make sure that you need to FOIL. So now this one, it turns out to be 9 minus 9 times negative 1. So 9 plus 9, which is 18. And then the numerator, so the numerator, we want to combine the like terms. So again, this one turns out to be negative 9. So negative 30 minus 9, negative 39. And then negative 30i plus 9i, then that'll be minus 21i. And now what we can do, we can reduce. Looks like we can reduce. And let's see. This one's by 3, but this one's 2. No, it's not. Let's see, 21i. It is reducible. Again, this part right here, that's 21i. Okay, let me just rewrite it. That looks a little bit different. So what we got here, 21i. So divided by 3, top and the bottom. So we do have negative 13 minus 7i all over 6. And that would be considered the simplest form. Again, there's no I down the bottom. There's no imaginary number down the bottom in the denominator. Okay, so graphing is similar to the one that we just did. The real number, negative 5. So 5 unit to the left. 1, 2, 3, 4, 5. And negative 1i, so down 1. And we do know that's array. Like that. So 29 basically just distribute FOIL. So that's something you guys can finish. 32 is quite similar to the one I just showed you for number 26. So you guys can finish that one as well. And let's see what else. Okay, so quadratic inequality. So anytime that you want to sketch the graph for the quadratic inequality. So again, so this one, well, I can do it either way. I can complete a square, or we can just use that the vertex form. I mean the vertex formula, which is negative b over 2a. So the y-intercept, that would be 15. So you just plug in 0 for x. So positive 15 or negative. Let me see. Positive 15. So it's all the way up here. So there's no way we can plot that point. But now let's find the... another thing that we can do, we can find the x-intercept. So that means we can factor it if that's possible. So there's so many ways that I can do it. Using the vertex formula. To find the x value of the vertex or the line of symmetry. Or you can factor it. So y is greater than or equal to x plus 5. x plus 3. So as you can see that -5, -3, those are the x-intercept. Because once you set that equal to 0, you can get the x-intercept. And then the vertex should be right in between those two x-intercepts. So it's right here at -4. And then plug in -4, so when x equals -4, so we do have y, it's greater than or equal to -4 quantity squared plus 8 times -4, and then plus 15. So 16 minus 32 plus 15. So -16 plus 15, which is what? -1. So the y value for the vertex, then that'll be -1. It's all the way down here. As you can see that the scale, the setup here is a little bit different. So -1 is down here. So we do know that the normal parabola is considered facing upward, so it's a solid parabola. But don't forget, it's inequality. Inequality, that means we need to shade the region, whether that is considered greater than or less than. So if anything that's considered greater than, so that means, well, what do you think? Is that going to be outside the parabola or inside the parabola? Well, as you can see that everything outside the parabola here, it's less. Okay, down here, it's less. So we need to shade a 1 inside the parabola. All the area inside the parabola. And that would be the inequality, the quadratic inequality. So check that. So number 34. Right here. Okay, so now 36. So how do you solve for the system of equations? Now the thing is that we do know how to solve for the system equation if that's linear, but this one is linear, the other one is quadratic. So what we can do, we can just solve for one of the variable in terms of the other variable. And then we can just put it into the non-linear equation. So for this one here, we can solve for y or we can solve for x. So let's just solve for y in terms of x. So we do have y equals -x minus 1. So back to the first equation here. So we can just put in -x minus 1 for y. So we do have -5x squared plus 3 times -x minus 1 quantity square, and then plus 3x, and then plus y. So y again, which is -x minus 1, and then minus 10. So basically what I'm doing here is just using the substitution technique. So -5x squared, let's just bring it down first. And then over here, -x minus 1, we need to multiply it, FOIL. We're using the binomial expansion, so we do have x squared, and then plus 2x, and then plus 1. And then the rest of this, plus 3x, minus x, and then minus 1, minus 10. Okay, so this one here, -5x squared, plus 3x squared, plus 6x, plus 3, plus 3x. Again, I'm just rewriting everything so I can combine the like term in the next step. So what we got is -2x squared, 6x, 3x, minus 1x. Then that would be considered ax. So 9x minus 1x, ax. 3 minus 1, then that's 2. 2 minus 10, -8. So for the quadratic equations, so now we end up with -2x squared plus ax minus 8 equals 0. So take out -2 or divide everything by -2. So we got x squared minus 4x. Again, I took out negative, so that's why you need to change the sign. Plus 4. Now you want to factor it. So x minus 2, x minus 2. So that means x is going to be 2. So you might be wondering that appears twice. It is. So don't worry about that yet. So if the same number of solution that appear twice, so that means the multiplicity would be 2. And now let's solve for y. So in order to solve for y, so you want to plug in that back to the second equation. the one that we isolate the variable. So y equals negative x, so negative 2 minus 1, then y equals negative 3. So there's only one point of intersections in between of the line and the quadratic equation. So it's 2 comma negative 3. So 38 is quite similar, but 38, instead of isolating the variable, so what you can do, you can subtract those two equations. Because that x squared, y squared, pretty much they end up with the exact same coefficient. So what you can do, you can just subtract those two equations. So equation 1, subtract equation 2. So this one got cancelled, this one got cancelled, ax minus 6x, then that'll be 2x. And then negative ay minus ay minus negative ay, also they got cancelled. And then negative 9 minus negative 11, so plus 2. Because that negative times negative, which is positive, so it's 11 minus 9. 0, of course, 0. So that means x is what? X is negative 1. So subtract 2 divided by 2, so x is negative 1. And then solve for y. So in order to solve for y, just plug in the number back to one of the equation. So plugging back to the first one, so we do have 1 square minus y square minus 8, because 8 times negative 1, that's negative 8. And then negative ay minus 9, so that equals 0. And then solve for y, so this one is a quadratic, so it's negative y square minus ay. So 1 minus 8, that's negative 7, so negative 7 minus 9, so negative 16. So take out negative, or divide everything by negative, so we got y squared plus ay plus 16 equals 0. So what I did here, I multiply everything by negative 1. And then factor it, so we got y plus 4, y plus 4. So y equals negative 4. So we do have the solution, which is considered negative 1, comma, negative 4. Alright, and now number 40. So we talk about the way to solve for the linear system, but now let's talk about the way to solve for the system with more than two equations. Okay, so anytime that you see the equation that has it has 3 equations, so the linear system, so that means we need to solve for x, y, z, or r, s, t. Well, let's do the complicated one. So let's say 39. So the strategy for doing that, the first step is always thinking about the variable, the first variable that you want to cancel. Okay, so the first variable you want to eliminate. So the first variable that I would like to eliminate here, so compare the equation. So for the first one, we do have 3 variable r, s, t. The second equation, we do have st. And then the third equation, we do have r, st again. So it looks like we want to cancel out the r. Okay? So once we cancel out that r, we can just combine it with the second equation. So in order to cancel out r, so what I'm going to be doing, so for the first and the third equation, so we want to find the least common multiples of 6 and 4. So the least common multiples of 6 and 4, then that'll be 12. So that means for the first equation, so we do have first, second, third equation. So first equation, I want to multiply by 2. So multiply everything by 2 for the first equation. So 2 times negative 6r, then that'll be negative 12r. Negative 3s times 2, then that'll be negative 6s. Negative 5t times 2, then that'll be negative 10t. Negative 23 times 2, then that'll be negative 46. And now I want to line up with the third equation. So the third equation, I want to end up with the same coefficient here. So for this one, I want to multiply by negative 3. So first and the third equation comparison. So negative 3 times 4r, negative 12r, negative 3 times 4s, negative 12s, and then negative 3 times negative 2t, then that would be positive 6t. And then negative 3 times 4, negative 12. Okay, so to look at that, so same coefficient, so that means we can subtract. So this one got canceled, negative 6s minus negative 12s, so 6s. And then negative 10t minus 6t, negative 16t. And then negative 46 minus negative 12, so that means you're adding 12, so it's a subtraction. So it's negative 34. Okay, so just checking the word here, making sure that everything is on the right track. It is. Okay, minus 34. And now, so compare the second and the new equation. So let's say this one is a brand new equation. So what we got here, it's s minus 6t equals negative 19. So that's the second equation. And then the new equation, the one that we combined with the first and the third one. So we do have 6s minus 16t equals negative 34. So this one's the new one. Again, we want to solve for one of those variables. So basically this one, I can just multiply the first one by negative 6. Or just multiply by 6. So multiply the second equations by negative 6. Because I want to combine them. So we got negative 6s, positive 36t, and then negative 19 times negative 6, which is positive 114. Okay, let's check that. So 9 times 6, 54. 1 times 6, that's 6 plus 5, 114. And then for the new equations, just carry that over. So 6s minus 16t, so that equals negative 34. Combine them, cancel. So 36t minus 16t, then that will be considered negative, positive 20t. So that equals 114 minus 34, then that would be 80. So that means t, which is 4. So we solve for t, and guess what? The next element, the variable that we can solve, we can just solve for s. So plugging that t equals 4 to the second equation. So we got s minus 6 times 4 equals negative 19. So s minus 24 equals negative 19. So that means s equals negative 19 plus 24. Then that would be, what, 5? So we got t equals 4, s equals 5. Now we can solve for r. So in order to solve for r, we just put it back into either the first or the third equation. It looks like the third equation it's a little bit easier. So let's put it back to the third equation. So we got 4r plus 4 times s. So 4 times 5, which is 20. And then minus, again, I'm using the third equation. So minus 2 times t, so 2 times 4, which is what? 8. So that equals 4. So 4r plus 12 equals 4. So 4r equals 4 minus 12, negative 8. So that means r is negative 2. So now we found them. So we got r, s, and t. So we got negative 2, comma, 4, comma, and 5. And the reason why this one is considered 3 variable, if you think about that going back to geometry, so the first variable is considered the length. The second variable would be considered the width. And guess what the third variable is? That's right, the height. So it's 3-dimensional. So x, y, and z, or r, s, and t. The length, the width, and the height. So let's say we do have a rectangular prism. You want to put it into the x, y, z space. So you guys probably want to check the other video that I have for the using the Algebra, the online graphing calculator. It's kind of like a decimal. So that one can show you. It also shows you how to find the 3-dimensional graph, the way to sketch the 3-dimensional graph. So now the last 2 problems, those are the word problem. You guys should know what to do. So once you've been able to set up the equation, they're considered a linear system, and then you can solve for the x, y, or the variables. Alright, so thank you for watching the video. So I'll see you guys next time. You guys take care.